In this video, I'd like to talk about multiplying and dividing inequalities. It's slightly different than, or slightly more difficult than adding or subtracting inequalities, or solving them using subtraction or addition. And that's because of this one very important rule we have right here. Okay, this rule is just something that needs to be memorized, and I can give you some intuition for it in example number 1, or example number 3. But when you are working out a problem and you need to multiply and divide by a negative number, in this case we're going to have to divide by a negative 5, you must flip the inequality. So now this greater than or equal to symbol will become a less than or equal to symbol. Okay, so that's one rule that you have to memorize for these. Everything else, as far as addition and subtraction and multiplying and dividing inequalities, this is the only rule that's different from simply an equality. All right, so let's get into this first example here. I have negative 30 is greater than or equal to negative 5x. Now remember, we're not just finding one single number, we're finding a set of numbers that will make this inequality true. And the first thing we're going to do is, well, I see that x is being multiplied by a negative 5. So I'm going to divide both sides by a negative 5. Okay? In doing so, I have to flip this inequality. So my new answer is going to be, well, negative 30 divided by 5, that's a positive 6, right? A negative divided by a negative is a positive. I'm going to have to flip that inequality, so instead of a greater than or equal to sign, I'm going to have a less than or equal to sign. These cancel out, and I'm going to be left with x on the right. Okay, so now, if I move my x over, if I kind of flip this again, I have x is greater than or equal to 6. That is my solution. Okay, so you have to remember to flip that inequality, and I'll give you some intuition in example 3 as to why we're doing that. But anytime you multiply or divide, in this case we divided, by a negative number, you have to flip the inequality. Let's see an example where you don't have to flip the inequality. Okay, in example 2, we have negative 7 is less than 7 over 3 times x. Okay, so you might see a negative in the problem, like here's a negative 7. However, we're not going to multiply or divide by negative 7. It's just in the problem. We're going to actually multiply by the reciprocal of 7 over 3. Okay, but that's a positive number. 3 over 7 is a positive number. If I multiply both sides by 3 over 7, I don't have to flip the inequality. I'm just multiplying by a positive number. It's less than 0, but it's positive. Okay, so these reciprocals will cancel each other out, right? If we just multiply them together, 7 times 3 is 21. 3 times 7 is 21. You have 21 over 21, which is a 1. Okay, so on the right, we have a x. I don't have to flip the inequality because I'm just multiplying by a positive number. And over here, I notice that these 7s cancel out, and I'm left with a negative, right? We can't forget that negative, a negative 3 on the left side. If I were to flip this around, just put the x on the left instead of the right, it looks nicer that way. But you can leave it like this, it's no problem. This is my solution. X is greater than negative 3. So I can put 0, I can put 1, I can put negative 1. They're all numbers that are greater than negative 3. And that's my solution. Okay, in this example, I just have a true statement here, a true inequality, right? We know that 5 is indeed greater than 2. That's true. If I was to multiply it by a negative number, let's just say, any negative number, negative 3. Let's multiply it by a negative 3 on both sides and see what it does. Okay? Well, on the left I have negative 3 times 5, that's a negative 15. Okay, on the right, I have 2 times negative 3, that is a negative 6. Well, here we have an issue. Negative 15 is actually less than negative 6, not greater than. This, multiplying it by negative, kind of put it on the other side of the 0. It kind of made it going the opposite way from 0 in the negative direction. So therefore, we have to flip that inequality around. And it's not a proof of why this works, but it kind of gives you a little intuition. It just kind of shows you that you can take a true statement and then multiplying on both sides, which normally would be okay if this was an equality. Now it actually kind of makes the number go in the opposite direction, so we have to flip that inequality.